Okay, so welcome back. Today we're going to take the next step in our discussion of how you can detect moving objects in streaming video. We've been talking about that in the previous videos, some of the building blocks of that. I encourage you to take a look at that. In this video, we're going to put it all together and build this C# Visual Studio Windows Forms application using EmguCV. And this application is going to allow you to take what you see here on the left, which is streaming video, live streaming video from a camera looking out a window. And we're going to be processing each frame of this video, and the result is going to be what you see over here on the right. And we're going to be utilizing what we talked in the previous video, which is what's called a background subtractor, which gives you a series of images like you see here, representing a change in the streaming video coming in. And as we discussed before, the way you detect motion is you detect a change in the colors between subsequent images in the stream. So this on the right is going to be what's called our background subtractor, which gives you the results showing you pixels representing any changes in this streaming video. And you can see here we've got some leaves rustling, and we're getting an indication of that with these little dots. So let's take a look at this application and see some of the basic components. Here on the left, we've got our streaming video. We developed that previously. We've also got a text box down here that's going to give us a little feedback, which I use in most of my C# applications, some debugging feedback and whatever. We also have over here on the right the option to either give this background subtractor images or the image itself. So I can select these radio buttons. I can have the image itself or the mask, and it will change it in real time. Now, if I've got the image, what I can do is I can show what are called the limit lines. And this is something I've added. You may not need it, but this allows you to select an area of the image that you don't want to be included in the determination if there's any moving object. So for example, in the upper right corner here, I've got some trees, and I really don't care about the motion of those trees. I don't want to be distracted by any motion up here. So these limit lines are user adjustable, and they allow us to say, okay, I only want to detect moving objects that are to the left of this vertical line and below this horizontal line. So we can move it, we can decide what we want to include in our evaluation. Those are called limit lines. We also have some readouts of the pixel position horizontally and vertically of these limit lines. We also have the option of, we can go to the mask here and we can see all this motion. We can say, well, I don't want all this noise, so I'm going to hit the noise filter, and you can see it filters out a lot of the motion of these leaves. I can also do what's called a threshold, which says there has to be a certain amount of motion before we're going to show it. And this boxes check mark is going to say, okay, if you actually detect a vehicle or a important object, we want you to draw a rectangle or a box around the object, as you just saw with the car going by. And you can turn that on and off, and you can see it's doing a little bit of that now with the noise. And you can see we've got a lot of stuff going on here that doesn't look very obvious in the streaming video, but it's clouds coming over, it's leaves moving, it's sun coming out, little critters running around. So there's a lot of stuff going on that you may want to just ignore, like you can see all of this being detected as an object when in fact it's just moving shadows. So that's why you might want to put on this threshold and noise filter and adjust those so you don't falsely detect stuff. So we also have, we're updating the UI to show, for example, the size of the image coming from the camera. In this case, it's 640 by 480. And what we're doing is we're resizing it to put it in these boxes. We're making it 1920 by 1080. We're also querying the camera to say, okay, what FPS are you set at? And you can see it's set at 60. And once we do the processing, after we've done all of this background subtraction, we're also calculating each time we receive a frame, we're figuring out how many seconds between receiving those frames and using that to calculate what's the frames per second of this processed video. So we've got the camera set at 60, but after the processing, it drops down to 30. So we've got that, we've got the selections, we've got start, stop, and we've also got a capture where we can, at any point in time, say we want to capture the streaming video and the resulting mask here, we can hit capture and it will send both images to files, to PNG files. So we'll grab this frame and grab the mask and save both of those as files that we can evaluate later. So that's the basic concept behind this application. Again, we're going to do basic capturing that we've done before, and then we're going to use EmguCV and OpenCV to do this processing on the video to allow it to detect moving objects. So let's go into the application and see how this all works. So here we are in our C# Visual Studio Windows Forms application. If you haven't done programming before, I encourage you to look at my beginner series for how to do a simple C# Windows Forms application. It's a wonderful way to do science, engineering, and UI applications. It's really great. What we've got here is the basic format of most of my applications. We've got some using statements we'll talk about. We've got my docs where we explain what this application does. A bunch of parameters we'll talk about. In our Form 1, we do the standard initialize component, initialize the UI with some default values, and then we have a new EmguCV video capture device using this camera index. I did multiple videos on EmguCV and how to set up the basic video capturing, but we'll go through this in a little bit more detail. And then I've got some methods and event handlers. And as you can imagine, there's a bunch of event handlers for the buttons and then a bunch of methods to do the image processing and so on. So the first thing we need to do is, as we showed before, and I'm not going to go through detail, you have to install EmguCV. So Tools, NuGet Package Manager, Manage NuGet Package Solution. Installed, I've got emgu.cv, .cv.bitmap, and .cv.runtime.windows. Again, we showed you how to do this previously, so I encourage you to look at that. We also need to set this for an x64, not any CPU. So make sure you look at the video where we did that. And we got to use some using statements. So as we did before, using emgu.cv, and then emgu.cv.cvenum, and those are going to be used for some of the image processing filtering tools. We need emgu.cv.structure, which is when we draw our limit lines, it's going to allow us to draw some lines. emgu.cv.util, needed for the vector of point. We'll talk about that. And then the using system.drawing, because we're going to use the bitmap class. Using system.threading.task, we're going to launch the image processing and it's its own thread to make things a little bit more easy. And then system.windows.forms. So now we've got our basic application. And what we can do is start out with designing the UI. And as you can imagine, we're going to have a couple picture boxes. We got one here that shows the raw streaming video from the camera over Wi-Fi. And then we've got one on the right that shows the processed image, which is generally a grayscale foreground mask showing the areas of motion. We've also got some track bars. I did a video recently on how to use track bars. And you may not need these, but these we're going to use to draw the limit lines where we can say only identify moving objects in a certain area and ignore the other areas. So we got a couple track bars. As with most of my applications, we've got a text box down here to give some user feedback to make sure everything's going okay. We've got some labels. This tells us what the dimensions of the frame coming from the camera, what is the camera frames per second, and then the processed and calculated frames per second. And then we've got a couple radio buttons to define this picture box on the right. Do we want it to be showing an image, the raw image, or the foreground mask? And those two buttons are inside a group box, and we talked about how to do that. Just put in a group box and drag and drop the radio buttons, and that will allow the radio buttons to only have one selected at a time. So then we've got 1, 2, 3, 4 check boxes. This first one is if we want to show the limit lines that the track bars control. This one if we want to do a threshold calculation in the grayscale foreground mask. This one if we want to filter out any noisy parts of the image. And then this one if we want the software to identify certain moving objects and put rectangular boxes around them. And other than that, all we've got is these 4 buttons that we're going to have button event handlers for. We've got the start, which starts the capture and the processing, and of course the stop. We've also got a button here that when you click this, it will instantly grab whatever frame is being displayed in our picture box, and also the process version of that, and it will save those 2 images, those 2 captured frames, as images that you can look at later and evaluate. And it will also do some nice stuff like give it the title of the image will be the a date timestamp. So it will tell you exactly when this was captured. And then we've got the button exit. So really, I assume you know how to drag and drop picture boxes and track bars and these check boxes and everything. We've talked about that previously. So now we have the UI all set up. We also need to make sure we have our picture boxes set to zoom mode so that the frame will fit inside. But otherwise, I encourage you to look at the previous videos for more detail on how to set this up. And here is our main application. So we've got our using statements, our docs, which basically says this app captures streaming video from either a camera or a video file and processes it. Presently, it detects moving objects in the streaming video by using EmguCV /OpenCV background subtraction functionality. We talked about that previously. It also allows the user the option of applying noise filtering, threshold filtering, and using track bars to define movable areas to ignore. It sets up an EmguCV video capture device, uses the image captured event to grab and process each image in the stream, also launches a task.run to perform the motion detection on a separate thread. So we've got that. We've got a bunch of parameters. I'll scroll through these. You can pause and just type those in. But basically, we've got some bools which define, do we want to stream the video, yes or no? So we can pause it or we can continue streaming. And for the right-hand picture box, do we want to show the image or do we want to show a mask? So we're defaulting to show an image. Do we want to filter noise? We're defaulting to no. Do we want a threshold applied? We're defaulting to no. And then here we are defining our mats. And we talked about that, EmguCV matrix, which defines each frame. And we're calling it public mat. And we're calling the raw frame coming in as frame. We have a mat called smooth frame, which is basically a Gaussian blurred version of that we talked about. And then we have the foreground mask mat, which is the grayscale image showing the detected motion. We have our camera index. When you set up the video capture device, you have to tell it what is the camera index if you've got multiple cameras. We've got 2 doubles that we're defining to be able to calculate the frames per second. And we'll show you how to use these. We're going to do a little bit of filtering, but this is just for frames per second calculation. Here we've got some definitions about the bounding boxes or the rectangles we're going to apply, and also the base frame width and height that is coming in from the camera. What's the dimensions of the images coming in from the camera? So we're going to show you we can use this minimum bounding box area to define that we only want things to be detected as objects if they're greater than a certain size. So we'll talk about that. Here we've got our image path. When we capture the image and the associated grayscale foreground mask, here is the path that we want to save it. And here we've got some date, time, and time span for calculating the frames per second. Every time we get an image captured event, we're going to calculate the frames per second. We're also going to define a system drawing.size. We're going to call it frame size, which says we want to take whatever image is coming from our camera. It might be 640 by 480 or something, and we want to increase it to 1920 by 1080, and we're going to use this frame size to do it. And here we are defining our EmguCV video capture device. We're going to call it capture, and then we're going to instantiate it later on. And here is the most important thing, our EmguCV I background subtractor. We're calling it background subtractor, which does the motion detection we talked about previously. So that is all of the parameters. Like I said, we've got the standard initialized component. We've got a method that we're going to just initialize the UI to some defaults, and we're actually instantiating our video capture using that camera index, and we're going to call it capture. So the first thing that's going to happen when we start up our application, we're going to do this button start. So we've got this event handler, and all this is going to do is say, okay, we are setting that Boolean we had before, stream video. Now we're going to say it's true. We're also going to subscribe to the video capture event, the event that comes with every video capture device. It sends out an event whenever it grabs an image from your camera. And we've got the video capture device, we called it capture, and we're subscribing this capture underscore image grabbed event that you can see down here below it. We're subscribing that event handler to this video capture image grabbed event. So every time we get an image coming from the camera, we will go into this event. And then we're doing capture.start to start up the capture. Now we can also, as we talked about previously, we can set some parameters. We got another video talking about camera parameters, very complex field. But here we know that we can set the frames per second of the camera to 60 frames rather than the default 30. It's going to be different on your camera, but here I'm just showing you can use an EmguCV enum.capprop or capture property.fps, and we're setting it to 60. That's because when you do the processing, it's going to slow things down, and your 30 frames, if it's set at 30, it's going to get down to like 15 or so. So you want to crank that up a bit so we get better response. We also are instantiating new background subtractor, and we're using background subtractor MOG2. Now we're not going to go into the details of that, but for now you can use that as the method for background subtracting. And here we're going to enable timer 1 to set that to true so it can update the UI every 100 milliseconds or 300 milliseconds or whatever you want. So that's basically it. We've got the capture being started, and all of the processing now is going to go to this capture underscore image grabbed event handler and to the timer 1 tick. So every time it grabs an image, it's going to go to this. And this is going to basically just grab the raw image from the camera, display it on the left-hand picture box, and then call the motion detection methods and start it off in another thread. But that's all this image grabbed event handler is going to do. So we're going to do a try catch, and we're going to try to retrieve a frame. We're going to start out for calculating it frames per second, we're going to say now is datetime.now. And when we're done with this, we will do the last, which will allow us to calculate frames per second. So if stream video is true, if we've got the Boolean set where we want to stream the video, the first thing we're going to do is define our new mat called frame, and that's going to represent each captured frame from the camera. And we're going to do a capture.retrieve, and we talked about this previously. If we have an image grabbed event, that means it has already grabbed an image. So all we have to do is do a retrieve. We don't have to grab it, we just retrieve an existing frame. So we're doing capture.retrieve, and we're assigning that to this frame. And now we have grabbed the frame, and we're going to say whatever width and height are coming in that frame from the camera, that's our base frame width and height that we can display on the UI to say, hey, the width and height coming from the camera is like this. and then we can resize that frame. So we're doing a CV invoke. We're basically invoking an OpenCV command using this EmguCV invoke to resize. And we're taking this incoming frame, we're making the outgoing frame the same thing, and we are doing a frame size, which is what we defined in the parameters. It's basically going to take this, if it's 640 by 480, it's going to resize it to 1920 by 1080. And then we're going to display that frame in the picture box. It's just the raw image. It's a resized frame, but it's basically the same frame. And to do that, we have to use the 2-bitmap function of the mat, and it will put that into the picture box. So once that's in the picture box, now we can go and process the image. So we're going to call process image, and we'll look at the bit, but it's basically going to launch another process to do some image processing depending on what the user selected. So then when that's done, we figure out a time span is the difference between last and now, and that is giving us, for each captured frame, it tells us how often are we capturing the frame, and then we can calculate frames per second. And then we're going to do a frame.dispose because we're done with this frame. We get a failure, it's just going to give us a message box that application failed. Actually, we can just make this as empty and it will just ignore that frame because we don't really care. But that's basically all it's going to do. And now process image is going to be a method we'll see that's going to do the actual image processing in a different thread. Now we also have this timer 1 tick, and that's just going to do a bunch of stuff to update the UI. And here we have our track bar, our horizontal and vertical track bar. This is just going to tell us what the text is. There's a label that's associated with that track bar. It's going to tell us what the actual values of those track bars are in terms of pixels or lines and columns in that frame. So we're converting the track bar horizontal value to string and setting that as the text for the track bar. Basically label up here and down here to give you real-time feedback. And then we can calculate frames per second. If the time span is greater than 0, there's actually time between received frames. We can go through this calculation. I'm not going to go through this in detail. It's a little bit overkill, but we're just saying that whatever the time span between frames is, multiply times 0.001, because that's in milliseconds. So 1 over that is frames per second. And then we can do what we talked about in previous videos, which we can apply a low-pass filter so we don't keep seeing these frame per second calculations jumping around 60 times a second. We can filter it out by saying we're taking our frames per second is going to be 90% of the old frames per second plus only 10% of the new, so it's going to kind of stick with the old one and only update it a little bit depending on the new, and then display that in the processed FPS, and then set FPS old equals FPS. So that's, again, you don't need to do this. We're just showing what the frames per second calculated is. And this is just saying if the user says, I want to show an image in the right-hand picture box, if that radio box image is checked, then we're saying show image equals true and show mask equals false. Else, if radio mask is checked, show image is false and radio mask equals true. And then if the user wants us to do a noise filter on this image, if that is checked, then filter noise equals true, else filter noise equals false. If the user wants a threshold calculation done, threshold equals true, else threshold equals false. And then we can also ask the device what frames per second it's set at. And we can do this using the capture.get, and we can feed it this capture property.fps, which we showed in the other video, that you can access. You can ask the camera some of its settings, and that's going to come back as a double, and that will tell us what the FPS is set on the camera, not the process, but what the camera is set at. And we're basically saying camera FPS is device FPS that we just calculated, and put that into the label. And then track bar horizontal minimum equals 0. Track bar horizontal maximum is whatever the base frame width is. And then track bar vertical minimum of 0, track bar vertical maximum is base frame height. So now we can do some calculations where we're using these track bars to say, hey, I don't want you to make a bounding box that's outside of the range shown by these track bars. So the bounding box right-hand limit is going to be whatever the track bar vertical value is, because we only want it to be to the left of that track bar. Only objects to the left on the road will be shown. Same thing with the bottom limit, is the base frame height minus the track bar horizontal value. Again, you don't need this. We're just doing it if you want to discard any areas of your image from having motion detection. And then the last thing is we're updating the camera frame base frame width times base frame height. So we're just updating the dimensions of the images coming from the camera. And that's it for this timer. Again, you may not need this. We're just showing you this one option to update the UI without having to worry about going into this 60 frames a second image capture. And then the other important thing is this button capture, where the user says, hey, immediately grab whatever image is being displayed and whatever foreground mask is displayed. This method grabs the present frame and mask images to a file with a file name that reflects the hour, minute, and second it was saved. So we're coming up with this timestamp, which is going to be the name of the file, and it's datetime.now.hour toString with a D2. We want two numbers, with an underscore plus datetime.now.minute toString with D2 plus an underscore plus datetime.now.second toString with a D2. So the name of the file is going to be the hour, minute, and second, and then we're going to save it using frame.save. Again, it's another method in the mat class, and it's going to be image path that we defined above plus this timestamp plus frame.png. So it's going to save to that path with the timestamp plus frame PNG. And then the mask is going to be the exact same thing. Foreground mask.save, image path plus timestamp plus mask.png. So they'll both have the same timestamp, but one will be frame.png and one will be mask. And then if we do that, it will update the text box 1 and say we sent the images to whatever that image path is. So that's it for the event handlers that we have to worry about. Again, button stop. All we're going to do is going to say no, stop streaming video. Stream video equals false. Capture image grab. We're going to unsubscribe from that event. We're going to stop the capture. We're going to disable the timer, and we're all done. And then button exit just as an application exit. So that's it for the events. And as expected, they're just going to call these methods. When we start up the application, we're going to do this initialize UI, which is just going to set defaults for the track bars, horizontal and vertical value. You can do that whatever you want. We're going to set the check boxes as some default values, and then the radio box, we're going to default it to have the image being shown. So that's basically just this initialize UI. And then the important thing is going to be this process image and motion detection. As we said, when we get a new image in the image capture, it's going to call this process image after it displays the raw image. And all this is going to do is it's an async method called process image, and it's going to launch a task. Now, we did a video on async and await and multi-threaded applications, and it's going to, in parallel, run this motion detection method you see below here, and then allow you to go back and access the UI while this is going off on a separate thread. So we can also add more methods here to do in parallel if we want later on. But here we're just going to launch this motion detection. So motion detection is going to be the method that does all the work, and it detects motion. And if the user wants, it applies thresholds, filters, and so on. So this is going to be very simple. It's just going to be one big try and catch. And the try, in our case, we're going to re-grab the existing frame. Now in the future, we may look at this and modify it. But for now, to make it easy, we're going to recapture whatever frame is there and call it frame. If frame is empty, we're going to return. We're not going to go through this. And then we're going to do what we talked about before. We're going to process the frame. And we're going to define a new mat, a new image called smooth frame. And that is going to do a CV invoke, basically a OpenCV. It's going to invoke an OpenCV method called Gaussian blur. And it's going to take our input frame and give us an output frame called smooth frame. And it's going to do a Gaussian blur using a system drawing dot size of a 3 by 3 pixel square that it's going to blur inside that square. So to start our motion detection, we're going to do a Gaussian blur, and then we're going to do the really important part of this, which is we're going to define our foreground mask, which is going to be the grayscale image that shows all the detected motion. So foreground mask is a new mat, and we're going to use this background subtractor we defined in the parameters. Background subtractor we're going to apply, and the input's going to be this blurred smooth frame, and the output is going to be the foreground mask, which is going to show all of the detected motion. So at this point, we have a foreground mask that has all the detected motion, and if you want, you could end it right there. It's not going to actually detect objects, and it's not going to have the filtering, but really it's basically giving you your background image, your foreground mask. However, if the user wants to do some more processing, like apply a threshold and noise filter, if threshold Boolean is true, we're going to call the threshold method. If filter noise is true, we're going to call the noise filter. If check boxes, if we want the application to detect objects that we've defined, like cars and people, we're going to call this bounding boxes method. And if we want to display the limit lines, we're going to call this limit lines method. So we've got a bunch of methods here that we're going to show that basically do the different processing: threshold, noise filter, bounding boxes, and limit lines. And then what we're going to do is, when all that's done, we're going to do a resize. We're going to resize the smooth frame to this 1920 by 1080, resize the foreground mask to 1920 by 1080, and resize the input frame to 1920 by 1080. And then we're going to call a method to draw the mat. So that is the main workhorse where we're going to actually do the processing and draw the images. So the only thing that's left now is these methods that do the subsets of that. So the limit lines, if we're going to draw the limit lines that are controlled by the track bars, you can imagine we're going to have to say, here's our frame, and we're going to have to define a point. If it's a horizontal line, it's going to be from the left-hand side of the image to the right-hand side of the image. We want to draw a line. So we're going to use a CV invoke, the line method that draws a line in this frame from point 0, which is the bounding box bottom limit, to point at frame.width, which is the bounding box bottom limit. And then we're going to use this MCV scaler, which tells us what color we want the line to be. And here's the vertical line, same thing. We're going to draw a vertical line in this frame of this color. So we won't go into that, but that's basically if you want to do the limit lines. Then the threshold is very simple. We're going to do a CV invoke of the threshold method, which takes the foreground mask as input, foreground mask as output, and then is going to remove anything below this range of 225. Pixel value is going to be 0 to 255. So it's going to remove anything below 225 and above 255. And it's going to do a binary threshold. So you can put these numbers whatever you want. I just chose some. And then we've got the noise filter, and we talked about that. We're going to use an opening operation which first erodes or decreases the white region of the image, hopefully to remove any noise, then does a dilate to re-expand the white region, and hopefully this will remove any random noise like our moving leaves and that kind of thing. We're going to do a CV invoke morphology EX. The input is foreground mask, the output is foreground mask, and we're going to do this open method, and I'll let you look into the details of how this works. The last thing is going to be bounding boxes, and this is going to be the way that we detect objects of a certain size that represent either humans or vehicles or something, and draw bounding boxes around it. Now, maybe in the future I'll get into more details about this. For now, I'm just going to allow you to look at this, and if you want to pause the video and type it in, we're going to use a vector of points, and those are going to be called contours. And then we're going to do a fine contours in our foreground mask. And then for each contour that we've detected, we're going to draw the bounding box, and we're going to show the image or show the mask. And again, I'll let you take a look at this and pause the video and type it in. But this is basically going to draw the bounding boxes around the moving objects. And then the last thing we have is for picture box number. In our case, we're going to do box number 2 is the right-hand side. It's going to draw a mat in the right hand in picture box number 2. It's going to be a try-catch. If box number equals 2, which is the picture box on the right-hand side, if the user has selected show image, picture box 2.image is framed 2.2 bitmap. Otherwise, if they said show mask, picture box 2.image is foreground mask to bitmap. And that's about it. So that's how you can make this motion detection application in C# Visual Studio Windows Forms. In the future, you may get into a little bit more detail about this. We're also going to look at, instead of having all these methods here, we might look at a generic image processor class so that we can expand this and make it a lot easier. But for now, this works pretty well. There is one issue that you may encounter when you run this. After 10-20 minutes, it may crash, and there's a reason for that we're going to get into. We're going to have to do some modifications, but we'll look at that later. But for now, that's about it for this one. If you like any of these videos, please hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.